Hi, everybody. Today we're going to talk just real quickly about conducting a t-test using Excel. We're going to look at doing a t-test for independent means and t-test for dependent means as well, and just kind of talk briefly about some of the assumptions and calculating the test and the procedures and steps involved within it. All right. So a t-test for independent means is used when assessing if there's a difference between the means of two or more variables essentially. So between two groups, you're looking at two independent groups. An example could be, as I indicated here, post-release treatment for parolees versus probationers. So if you want to compare the effectiveness of a drug rehabilitation treatment out in the community, and you have a group of probationers that come in within a county, and then parolees who are released in the county. These might be two isolated groups. Or if you have, if you want to compare police departments, if their effectiveness on preventive patrols, or comparing the differences between that, or Texas versus New York or something, or just any two different groups. That you want to compare the means and see if there's significant differences between those two. So one of the assumptions is within all statistical procedures, there's certain assumptions that need to be adhered to. This really becomes a lot more relevant later on with the more advanced statistical tests that we do, but the assumptions for this really become much bigger factors when the sample is small. And when you have small samples, the assumptions are likely to be violated. Now, the only assumption really here is that the variability between the two samples is equal. So just moving forward with that. Here is kind of the equation. I just kind of included the equation for you just to see what the t-test for independent means looks like. So you have sample 1 and sample 2, the two different means, and how you're calculating that, and you're looking at the variation between the two. I don't necessarily need y'all, I'm not going to go step by step through the equation and all that, but within statistics you want to understand that what you're usually looking at is means and variation. That's why we spent a lot of time at the beginning of this course looking at the different ways to calculate the mean, median, and mode, measures of central tendency versus variation versus the standard deviation, and all those things. The spread between, how far things deviate from the mean and move away from the mean. So that's really what statistics is when you think of things on a larger scale, just looking at means and variation and comparing it with other variables based on different metrics and accounting for different factors that might come into play. All right. When you break statistics down, really that's what you're looking at, means and variation. But steps for computing statistic, the procedure, the things you want to think about when you're walking through this type of stuff is understanding your null and research hypothesis. So if we want to compare the differences between parolees and probationers and their success of an anger management program, and looking at whether or not they recidivate based on if they went to this type of program or whatnot. Well, the null hypothesis is that there's not going to be a difference. The research hypothesis would be there is a difference between the success rate of probationers and parolees who attend this course. A directional research hypothesis would be parolees are going to be less successful than probationers once they are administered a treatment, or probationers might be less successful than parolees once administered the treatment. So those are things you want to think about, and they're always going to follow you. You have to understand what the null hypothesis is, that essentially there's no difference in between. All right. From there, you want to set the level of risk associated with the null hypothesis. In the social sciences, generally we set it at the 0.05 level here, the alpha. We call it the alpha level at 0.05. So essentially it's the probability that it's likely to occur within a population. So 95 times out of 100 is what 0.05 essentially means. So select the appropriate test statistic, and we'll look at a little chart, and there's various charts that you can utilize and to understand what statistical procedure perhaps best applies to the test you want to do based on the data you have. So determine the critical value, compare the obtained value, and make a decision about the the alternative hypothesis, whether you fail to reject the null hypothesis or reject the null hypothesis, conclude that the alternative is appropriate for this. So this is from your textbook, but there's charts all over the internet, and if you have a data set and you have ideas about how you want to test something, this is kind of a good flow chart to follow. So are you examining relationship between variables or examining differences between groups of one or more variables, yes or no? And so I'm examining differences between groups of one or more variables. Are all the same? Are the same testers being tested more than once? No. So it's not being tested more than once, but you're looking between different groups. How many groups? 2 groups, so I can do a t-test. If I'm doing more than 2 groups, we do a ANOVA, analysis of variance, and we're going to talk about that in the future. But for now, we can isolate it down to the t-test for independent samples. And we're also going to do an example later on in this video at the very end of looking at a t-test for dependent samples, and is when looking at a pre to post test. Before and after type of test. This is comparing 2 different groups, but if you want to look before and after, that would be a dependent t-test for dependent samples test. So interpreting your results, this is kind of how the best way to lay things out. So if you want to write it up and type something up, you're calculating a t statistic, and it equals, this is the t value that you're achieving, and this is how you'd want to document it, that it is acceptable at the 0.05 level of significance, right? So t represents the test statistic. So here we're doing a t statistic. 22 is the number of degrees of freedom. Degrees of freedom is generally n minus 1, the sample size minus 1. Since we have 2 samples, we would subtract 2. There's different schools of thought on this, but for now, just as simplistic as that, just let that be the case. N minus 1 when you think of degrees of freedom, when you look at a sample, okay? It's basically the sample minus 1. It's to reduce the probability of type 1 errors from occurring, essentially. So negative 2.675 is the obtained value from the formula, and 0.05 is the probability. So this is the test statistic that was achieved, and that's the probability of it occurring within the population. So I got an example that we're going to work through real quick that highlights these numbers, so we'll come back to it. So we're going to conduct a t-test for independent means, and essentially this is some made-up data. Just for what I'm saying is the number of arrests in Dallas versus the number of arrests in Houston over 12 months, okay? It's good to know the mean, and if y'all remember how to calculate the mean, just do average for this column, drag it down here, and that's the average here, and I can just take this and drag it over here, and on its face you can see that, well, there is a significant, well, you can't necessarily say it's a significant difference, but if you were interpreting this in a descriptive manner, you would say, well, the mean number of arrests in Dallas is about 202 per month, where the mean number of arrests in Houston was 287 per month. Now, we want to understand whether or not that value is significant, right? If it's statistically significant, or if it's due to some random chance or random error or all these other factors that might be involved. To do that, we can conduct a t-test. So we're going to go here to the data analysis tool, and we're going to use the t-test sample assuming equal variances, okay? Because we're going to make the assumption that the variances between the two are equivalent, okay? So variable 1 input range, this is going to be the Dallas one. So we're going to scroll through here. Notice it goes from B2 to B14, and that's correct, B2 to B14. And variable 2, we're going to look at Houston, do the same thing. All right, we're including the labels in it because I highlighted it. B2 and C2 are the label, so we're going to include those. And the output is essentially where you want to place the output itself. So we'll put it here, okay? And it'll generate values that we're interested in looking at. So as far as the hypothesis is concerned, we didn't necessarily make a directional hypothesis. The hypothesis would be that there is a difference between the number of arrests in Houston and Dallas, okay? unless there's evidence to suggest that there's more in Dallas or more in Houston. We would just make the assumption that there's a difference. That's an alternative hypothesis. The null hypothesis would state that there is no difference between the two cities in the number of arrest rates over each month. But anyway, so the T statistic here gives you one-tailed and two-tailed tests, and that's the probability level. Anyways, before we get there, we want to understand, so there's 12 observations. So it's a sample of 12 for Houston, a sample of 12 for Dallas, which equals 24. 12 plus 12 equals 24. Minus 1 of the 12 from Dallas, minus 1 from the 12 of Houston, and then your degrees of freedom equals 22. From that, we see that we got a T statistic value of negative 2.674, right? And then we're looking at a two-tailed test statistic because we didn't give it a directional. And here, the T critical value is 2.073873, right? Thus, we know that the T value exceeds the critical value here, and so we can reject the null hypothesis and conclude that there's a significant difference between the two values, okay? Hopefully this stuff can show up to y'all, all right? So these are the values I was talking about earlier. So this is your T statistic value, how it's negative 2.675, and it's less than, likely to occur less than 5 times 100. So it's significant in that regard. So we know there is a significant difference between the two. And this is how we would interpret our result. So you can see that here. The T statistic, the P value, is actually 0.01. And let's go back here real quick from current slide. So this is how you would interpret it. This is how one would write it up in an objective format without any subjective influences. So you could put the means there. You could say that, well, there's 202 arrests on average per month in Houston. There's 287 arrests per month on average in Houston. If I didn't say Dallas wrong, but and thus we conducted a t-test to see if there's a significant difference between the two. The results from the t-test of the independent means indicate that P, with the degrees of freedom of 22, equals negative 2.675. Thus, one can reject the null hypothesis and conclude that there is a significant difference in the monthly arrest between the Dallas and Houston Police Departments. Okay, and the T value, if you want to be more descriptive, the T value exceeds the critical value. And where is the critical value? Well, your textbook offers charts. You can go online and find charts. But if we look here, we see a critical value for with degrees of freedom. This is how you would interpret the results. Degrees of freedom of 22, as we said before. At the 0.05 level, it's only 2.074. And if you look back here, our achieved T value is 2.675. So it exceeds this critical value. So it actually exceeds it at the 2% level, right? And it falls between the 1% and 2% level. And we should see that within our results here. And then we see P equals 0.013. All right. Hopefully that stuff makes sense, and I didn't go too fast through the whole thing. But that's how you would interpret it. All right, and be concise with your interpretations, because these are objective facts. These are statistical facts. These are numbers that exist within the samples that are compared. So it's very informative. You don't have to say I think, I guess, Just be specific with the numbers. If there is no significant difference, we'll just report that as well and fail to reject the null hypothesis. There's not a significant difference because the T value does not exceed. Thus, the means between the two cities does not differentiate. On a monthly basis, the rest doesn't mean anything, essentially, is what one would say. So that is for the independent means. Calculating that result. So I'm just going to talk real quickly about doing a t-test for dependent samples as well, the before and after test. So if we want to look at the effects of a treatment before and after the fact, certainly I calculated the mean here. And say if we're looking before treatment of 20 subjects and after treatment of 20 subjects, say for an anger management class to see if it was effective. Their their values on their anger score versus their values afterwards, after receiving treatment, okay? Simply, you can look at the means here. You could say, well, the before mean value for participants before the treatment was 32.85. The mean value after the treatment was 36.95. Now we want to take it a step further and see, well, that's fine and dandy. These descriptive results look good, and it does suggest that there might be a difference, but is it statistically significant? Well, we can test for that. Since this is a before and after type of test, we can go to our data analysis tool, and we can use the paired Ttest for paired two samples for means test, okay? And here, it's still saved, but I'm going to go the before treatment here. Got that column in variable one. Oh, no, I messed it up. I'll put it in now. Just put it in the variable one range before treatment. That's there. What is this? T22. That looks good. And the after treatment, we can do the same here. We included labels, and we're going to put our output. Just put it right here. Okay. And then we'll click OK and look at it run. Now here we would, the null hypothesis would be that there is no differences between the treatment of an anger management program, right? That anger management doesn't have an effect on people's level of aggression or people's happiness or whatever before and after treatment. But after running this test, that would be a directional hypothesis would say that there is a significant difference from the before to after treatment, right? So here we might look at the one-tailed test because it is directional to some degree. The statistic as well is the degrees of freedom. So you have 20 subjects here, -1. N -1 is your degrees of freedom for this type of sample. We would look at the significant value for a one-tailed test and figure it out. It is less than 0.05, right? We can also look at charts. I didn't include a chart here for this test as well, but the charts are in your textbook, and that's how you would calculate that, right? And you can also look online for those types of things. So hopefully this video helps y'all think about these things and interpreting. I want y'all to really focus on interpreting, understanding your null and research hypothesis and what these values mean and why you're calculating, okay? Why you're calculating them and when you would calculate them. So that's why these charts are included within your text. There's also other charts out there, so if you have questions about how am I going to perform this statistical test, what one will apply, well, these flow charts are examples, and they're very helpful in getting you to the right place. So today we got through the t-test for independent samples and t-test for dependent samples. We're going to move on to ANOVA, a simple analysis of variance. They call it ANOVA, A-N-O-V-A. And we've already completed the one sample Z test as well. So hopefully this video helps y'all, and good luck. Y'all take care. Talk soon.